AS-Level Graphs of Functions. Exam Preparation Questions, Part 2. Let's look at example 2. The function f is defined by fx equals, and this is the restrictions on the domain. The function g is defined by this, and they give you unknowns there at the restriction, where a and b are constants. Find the greatest value of a and b, which will permit the formation of the composite function gf. Now, this is very important that I'm going to read you this sentence, because this is almost leading to that they like to ask the range of composite functions. Can I just take you back? If I take you back to example 1, always remember this. If they give you a composite function and they put it equal to a number, you're going to get solutions. You're going to get values of x. Then always remember that that inner function, the one there, that function will determine what solutions will be valid and what solutions will not be valid. Keep that in mind. But that is if it's equal to equation. But now, if they go and they leave it open, please remember, do these questions like this. The composite function gf, to get the domain of gx, find the range of fx. So you take the inner, you have the domain, okay, there is the domain, but now substitute that values in to get the range, okay, of this inner function. And that range will be the input in G. So that domain, that range will become the domain of G. Okay, so keep that in mind. This is how we're going to approach this kind of sums. So what I'm going to do is I'm first going to substitute that values now in F. So if I substitute, I get 24. If I substitute the 7, I get 8. So I know that the range will be y is bigger and equal to 8 and smaller and equal to 24. And that's what I said. Find the range. That's the range. That will now be the inputs in G. So that will become now. So if the composite function, the range will become the domain, then this will just become the domain because it's going to be the inputs now in G. So it's going to be 8 and 24. So instead of writing the y, because that was the range of fx, and this is now the domain of gx. Okay, and that is the values that they want. And I'm not going to, in this example that I'm giving you, example 2, it's not really testing it. I was really struggling to get an example still looking like this, but I'm going to follow it up in this video with examples where I make use of this. So this example is actually just to test if you can find unknowns or in terms of A. But still, it's not a difficult example. So stop the video and do try now 2. Again, you can continue the video as soon as you are finished. Okay, so let's start. The function f, okay, so let's start with number A. The function f, and what is f? X. Again, they just put it in the other form, but it's fine. Just rewrite it in this, where a is a constant. Express fx and x in terms. Now, it's again, can you see? They are asking you they are actually asking you 2 questions in A. So make sure you answer both questions. Okay. Now, I prefer, it's just to help me. So as soon as I see a double F, I'm just rewriting it again. And it's just, I like to just draw the lines to just make sure I'm not making unnecessary mistakes. So it's like I will now take this one and I will put it in the place of x, always x in there. So I'm going to say f, x, so f in x. So make sure, and I'm just going to play around a little bit with colors now to just show you. A minus 2x, which was that, and then close the bracket, and that is what I substitute. So if I'm going to simplify this, it's going to be a minus 2a plus 4x, and that's going to be negative a plus 4x. Okay, so express f(x) in terms of a. So basically, that is going to be your answer there. Okay, now I'm going to go for the inverse. So let's just start again with the function. Just want to use another color. So that was the first answer that they want. So if I start with another color, I'm just going to say a minus 2x. And now inverse, easy. Make it a y. Where you see a x, make it a y, you make a x. And where you see a x, you make it a y. Okay, and then you take it over. So it's 2a equals a minus x. Okay, I go up. I divide 2. I divide 2. So I'm getting f minus 1x. Don't forget to write your inverse notation. And it's going to be a minus x over 2. And that is 2 questions in A. That's what they want. Okay. Now they say that this is equal to this. Okay. And now they want to find x in terms of A. Okay. So basically, I'm just going to put it equal to each other now. So I'm going to say f(x) is equal to f minus 1x. Okay, so let's just put it, so it's negative a plus 4x equals a minus x over 2. Okay, so if I'm going to do that one, now I think the best will be to get rid of the fraction. So put this over 1 and cross multiply. So I will have 2 negative a plus 4x, and that's a minus x. And now just remember, I'm looking for x in terms of x. So it's negative 2a plus 8x equals a minus x. Okay, so get the x, all the x terms on one side. So 8x plus x equals a plus 2a. And that's going to be 9x equals 3a. I divide 9, and the value of x is a over 3. And that is your answer. So this was not really connecting so much to the example. That was more for me. I just wanted to put this brilliant example, which was an introduction to the examples that I'm going to do now. Let's start with example 3. Express this in the form. They love this question in functions. Okay, and it's a very easy one. The function f is defined by this, and you will always see that this is the same as this. Okay, for x is smaller than k, where k is a constant, so they don't give you the domain. Okay, now let's start first with number a. So first, let's just make that space, so plus 7, and then take that term. I want to make again bigger, that you can see better. And then take this term, and just divide it by 2, and then square. And then whatever you add, you must also subtract. And then this is your complete square, so it's that x. It's that inside, so it's negative. So negative 2, or you can say it's that negative. So square, and then you simplify here. So remember, this is going to be 4. So 7 minus 4, it's going to be 3. Okay, now, usually, if you want to find inverse of a quadratic expression or equation, then you must have it in this form. Okay, so let's just go. There, we did all that. Where k is a constant, they didn't ask. State the largest value of k for which f is a decreasing function. Okay, so now you can find now the turning point. So what is the turning point? It's 2 and it's 3. So if x is smaller than k, f is a d when k is 2. Because if you, and I'm just going to, I think I did it here. Yes. Here on the sketch, you can always make a rough sketch. So the sketch is coming like this, and there was the 2 and the 3. So there was the 2 and the 3. Do you see that? The turning. So if it's going to be a decreasing, do you see? So then this value of k will be 2 on the turning point. Okay. So remember, it's the x value because it's x. Can I just take you up? It's x is smaller than. So for this decreasing, the decreasing means it's this part, it's not that part. So that part, oh, I don't think you can see. It's not that part. That's the increasing. That's the decreasing. And it's doing that turn on the turning point, which is there at x is 2. So k is 2. Okay, then we go on. The value of k is now given to be 1. So don't forget. So now, if you're going to substitute it here, can I just show you? Then it's going to be x is smaller than 1. And that's why you see that I was making the graph there. I found the y value also. How can you find it? Just substitute it. Okay. And then, so if you substitute to find that y value, I just substitute the 1 in that equation. So it can be 1 minus 2. So it's negative 1 squared plus 3. So it's 1 plus 3, which is then 4. Okay, but it's not necessary now. So find the expression for the inverse, because now you can find the inverse. As long as it cannot be over the turning point, cannot be over, but it can be shorter. It can any place be shorter to that side. Okay, so I must have it in this form. That's why they let you do it in A. So make it y is equal. Okay, then where you see a y, you make a x. Where you see a x, you make a y. Now you make y the subject of the formula. Take that over. Take the square root plus minus. And then you swap it around. Now, this is still open. This is still open. But as soon as you find that inverse, remember, we are with the negative side. Are you with me? And that's why you take, if you see here, I must take the negative option there. Okay, for the inverse. Because k, remember, k is 1, so I'm on the negative. If it was that it was on this side, you would have go for the positive option. Okay, so if k is smaller, okay, what did they ask also? Now, remember, they like doing it in functions. They like to ask more than one question. So let's just read always the question again. So find the expression. So that's what we did. That's the first part. But now, state the domain of the inverse. Now, remember, the inverse, and I'll show you now, I'm going to take you back. I just did the graph, but it's not necessary. The graph will always be a reflection in the line y equals x. But what I must do now is I need that y value, which I have, because I showed you. Can I show you here? If you substitute 1, you get 4. But now I'm going to take you back to this. Sorry, I'm just previous. I want to take you back to the beginning. And this is very important. This is what I'm playing now with. Is that if the domain of the function will be equal to the range of the inverse function. And the range of this function will be equal to the domain of the inverse function. So this is very important that you remember that. If it's a function, because it's a reflection in the line, meaning that say, if for example, that this point is 0, 1, then this point, always a reflection in the line y equals x, will be swapping the values 1, 0. Okay, and so you can go on. So if this was say 4, whatever, I cannot see what, okay, so let's make that one. Say for example, it was 4, 9, then the reflection here will be 9, 4. So the x becomes the y and the y becomes the x. That's what we did in the method. Okay, so let's just go back. Let's go back. So it's just a lot of thinking in these questions. So what did they ask you? And state the domain. So without drawing it, you have the range. You know that the range of the original function, the range, I just want to see if the range of the original function, there's the range. Can I show you there? So, okay, there's the point. That point, as I said, it was out. It was the turning point, but it was not the part. They made it shorter. So the range is y is bigger than 4. Okay, it depends if the value is included. Now this is not included, so that's why that value will not be included. So it's just, so the range will be y is bigger than 4. So what will be the domain of the inverse function? And you see it on my sketch. I made the sketch. So the value of x will be bigger than 4. Okay, so, but without the sketch, but if you struggle in the exams and you just want to figure it quickly for yourself out, just make a very rough sketch and make sure that you get that mark. Okay, so now comes the question. And this is really a challenging question. So it takes a lot of thinking. So now they bring composite in. So the function g, now they bring the g in. So there is the g now. And there they give you the domain of g. Find an expression for g, fx, and state the range. Okay, now if they bring in, I can do it like this. Now let me just read for you. If fx is this and gx, so first just do the algebra. Substitute the one into the other one. So basically, I'm going to take f and I'm going to substitute it in there, in g. Okay, so there I substituted, don't forget your -1, and I simplify it to there. Okay, so that is now my new function, but it's also very difficult then to draw, so just leave it first. So in gf, the range of fx, because remember, the input function is fx. Okay, so in gf, the range of fx, so x is bigger than 4. Don't forget that. We have that. We wrote it there on top. Becomes the domain of gx. Okay, for this composite. So x is now bigger than 4. Okay. So if I now, in this g, I substitute 4, I get 2/3. Now, what I did is to help you a little bit with the sketch so that you just understand it a little bit better. So the range of gf or g now is, and this is on my sketch. Do you see? There was g. Did you see that? Now that is the point 4 that I substitute, and I get the y value was 2/3. There was 2/3. But I'm asking you the range. So what will be the range now? The range, remember range is y values. It will just be that 2/3. Do you see? And it's not going to cross that line. So 0. So 0 and 2/3. There I showed you the graph. And it's going on there. But it's just between that little space that it's occurring there. So the range of gx will now be this. Okay, so remember what you do. Can I just repeat this? Because we're going to, there's a very nice sum that we're going to follow this again. What you do is you first get your new function. Okay, now you can also substitute in your new function, and I think that's how I did it in the textbook. But I want you also to expose you now to this one. So if the range, I have the range of this from my sketch, okay, I have it from top, I'm taking this, and it's becoming now the domain of g, because g is not the inner, it's the outer one. So I substitute and I get that 2, 3. And now I must just know, and it's actually good if you have a bit of a sketch that you know how this graph look. And can I just show you how I came to the sketch? The value cannot just be 1, and that's why it's the asymptote. But then it's just almost like a hyperbole. That is the rational function, and that's how I can draw it, and that's the answer. It's a bit challenging, but as I said, just make sure they love asking the same type of questions. So try to conquer it on one and then try to do it in the next one. But let's look at the examples. Let's look at example 1. Remember, stop the video, try to do it on your own, reflect on the example 3, it's really going to help you, and then continue the video and check your answer. Okay, let's start with number 1. The function f and g are defined by, okay, so fx equals x squared minus 4x plus 3, and x is bigger than c, where c is a constant. Okay, gx equals 1 over x plus 1, where x is bigger than negative 1. Okay, express fx in this form. Now, if they say just in the form, you can do it like this. It's fine if you write it then in the function notation and then say x squared minus 4x. Now, I like always to write the 3, and then I'm just going to show you. So, plus, you say negative 4 over 2, and you square, minus, whatever you add, you subtract, negative 4 over 2, and I square. And now, if I make the bracket, it's going to be x. This is the negative, or you can say that negative. And it's always that inside, not the square. So it's just 2, and the square is out. So it's a perfect square. And then this is going to be 4. So it's 3 minus 4. So this is going to be negative 1. Okay. Okay. Now, they say, always read the question. Express it in this form. Okay, we did that. I can already see the turning point, but I'll write it down as soon as I need it. Okay. So number B. It is given that f is a one-to-one function. Ah, there it comes. For it to be a one-to-one function, it must be restricted at the turning point. So take the smallest part of it. So now, the turning point of fx, now I'm going to write it down, is going to be, change that sign to a negative 1. Now, if I'm not going to make the sketch, but if I just make a very rough sketch, okay, I can actually start making. Just remember that if it's 2, that is 2 and negative 1. And due to that, it's almost like the legs is going up. Okay, let me just, just want to go a little bit lower. Okay, and that should be at negative 3. Okay, but doesn't matter. That's 2 and negative 1. So where will I, so read again the question, so the turning point is there. State the smallest possible value of C. So C must be bigger than 2. Can you see that? Okay, so the smallest possible value will be C is equal, therefore, C is equal to 2. So that's not the highest because the legs is not going like this. It's going up. So the smallest will be that 2. Okay, at the turning point. Sorry, it's just my point is not very nice there. It don't look like on the turning point, but it's on the turning point. Okay. Okay, so let's start with number C. There is number C. Find the expression for the inverse and state the domain. Now remember, if I go a little bit down, let's rather take it green, that's a quadratic function. So if a quadratic function, I want to get the inverse, it must be in this form. So start by saying fx is equal to x minus 2. So it must complete the square on one side. Okay. Now I can say y is equal to x minus 2 squared minus 1. Okay. And now I'm just going to make it a x, make it a y, then x plus 1 equals y minus 2 squared. Then plus minus x plus 1 equals y minus 2. And then, before I swap it around, I'll show you now what side. So plus minus, okay, x plus 1 plus 2. Okay, let's just get that plus 2, or 2 plus minus. Doesn't matter. 2 can also be in front. Rather, let's just put it rather in front. Okay, so I'm taking it over. So it's 2 plus minus equals. But now remember, you are working with the increasing function. Do you see? So if I look at my graph, and that's always good to have, even this is a very stupid, rough graph, but it's still going to help me. So I can see that it's the increasing part. Now, unfortunately, that was also blue. That's the increasing, and that was the decreasing part. So the increasing will be representing by the positive. Okay. So by the positive. So I can go and say f minus 1x, and then it's 2 plus, and then it's the square root x plus 1. That's the inverse function. But I'm not done. As I said, I love asking two things in this. So state the domain. Now if that is the inverse, so remember, it's now my sketch is not really nice. It's nice there, not. But it doesn't matter. If I must now go, first find on the function that point at 5. Okay, so let's just find. If that was 5, if I'm going to say, and I'm going to do it here, I just want to use another color. If I say f5, let's just find first, because I need the y value. So if I'm saying 5 minus 2 squared minus 1, so that is going to be 9 minus 1, and that's 8. Okay, so I can see that that is the 0.58. So a reflection in, and as I said, my sketch is now not nice, but a reflection in the line. So if this is fx, then if I have a reflection f minus 1x, then the point will change around. So then it will be 8 and it will be 5. So it will go on there from 8. So if I'm going to ask you the range, now remember, if I'm asking, no, let's just go to the question. Sorry. It's not, solve the, I'm here, no, I'm with this, and state the domain. Okay, the domain is equal to that range. So I can just end by saying, therefore, the domain of f minus 1x is going to be x. And now remember, can I show you again? It was that range of f that becomes the domain. So it's going to be x is bigger than 8. Okay, because it's going to be can I just take this? It's going to be to this side, bigger than 8. Okay, so let's go on. The next question. Find an expression and state the domain. Now, the next one is challenging. Find an expression for GF. So now it's a composite, and state the range of GF. Now, I'm just going to make a little bit of space. And I'm going to, and it's almost like the previous one. But as I said, it takes a little bit of thinking. So, but I just need space. Okay. So, let's start. Find the expression. Now I have my expressions. Okay, this is now number 1D. I have fx is equal to, it doesn't matter what form, I think it will work in this form. And I'm bringing in, and remember, they said it's now c is 5, so x is bigger than 5. Okay, but find an expression now, and gx, I'm bringing in gx. Oh, it was already in, so x plus 1. X is bigger than negative 1. Okay, so basically, if I'm going to do a question now like this, so I'm going to say, find an expression for g. So first, before we do anything, let's just first find g f x. So I'm going to take x and I'm going to put it in g. So I'm going to get 1 over x squared minus 4x plus 3 plus 1. So I'm going to get 1 over x squared minus 4x plus 4. That is going to be my function. Now, but now I start with that process. Okay, let's just start there. So I'm going to say the range. So can I just say the inner function? This is the inner function. Okay. So what is the domain? Let's first say the domain of fx. Okay. So the domain of fx is going to be x is bigger than 5. Okay, we have that. So that's the domain. But that is going, what is the range now? Because the range is going to be the input. So the range of fx is going to be, and remember that was that y, we did it in the previous, was bigger than 8. Okay. But now this range becomes, keep to read, the domain of gx, because that's the inputs. That's what you're going to put in now in g. So basically, x is going to be bigger than 8. Okay, are you with me? So now, if I want to find the range, I'm going to substitute that in g. Substitute 8 in. So if I'm going to say g, and I put 8 in, I'm getting 1, and that is 8 plus 1. And that is going to be 1 over 9. Okay, are you with me? Now, I can show you on a sketch. So that is going to be the range. But just to see, how is G looking? How is the sketch of G looking? Because I have all the information now to make the conclusion. But how is G? Now, can I just go back? If G was x plus 1, it can just not be equal to negative 1. So there, at negative 1, is the asymptote. Okay, now it works, and I'm not going to go too much into detail now. It works like a hyperbole. So it's going to be like this, and it's going to be like this. Okay, so what do I have now? So that is going to, it's not going to cross there. So I have that at 8, here, at 8, let's just get another. At 8, it's going to be there, 1 over 9. Okay. So if you have there 8 and you're moving on, because it's bigger than 8, do you see? It's bigger than 8. It's just going to be to the 0. So it's that little bit, but it's not crossing 0. So I can go and to the conclusion saying, therefore, the range of, and now just make sure you are writing GFX. And I'm just going to say, okay, let's just go GFX. And it's bigger than, because there's no equal, 0. It's that little bit there. And it's smaller to that 1 over 9. And that's how you find the range. I'm creating the video today, 20 June 2023. And I believe it's now holiday for all the learners. So if you want to go and buy a copy of the mathematics textbook y equals mx plus c, you can go and check out in the following bookshops. And it will now be a very good time to go through the first semester's work and to make sure that you are ready 100% before the next semester starts. And then also, this is more for the teachers. Just remember that all the textbooks are on the the NIET catalog. So this is also the time of the year that schools order their books, send the information in, and make sure that your learners is having a copy in front of them next year.